Hey all, and welcome to your next week of Intro to Calculus. We're going to keep talking about integrals, and we're going to talk today about finding integrals using geometry. And you'll notice here it doesn't say estimate, it says evaluate, and that's because we're going to talk about some of the strategies we have to find exact values for integrals. So get yourself ready for notes, and we're going to get started. Now, for a lot of these problems, you're going to want to start with a graph. And once you have a graph, you want to remember that the integral from a to b of the function f of x dx, which just tells us that we're dealing with our x variable, this is equal to the area under the curve, or the area between, all right, this is the area between the curve made by f of x and the x-axis. That's what the dx tells us. So if we're looking at our graph here, I'm going to start by saying, all right, here's my axes. And my function here is x plus 3, right? These are our bounds of our integral. Our function is just the part here, and we're dealing with the x-axis. So if I graph this, x plus 3, it's going to just be a nice line with an intercept of 3 and a slope of 1. Now, what we're asked to do here is find the area from -2 to 4. Because that's what our bounds tell us here. So I am asked to find the area of, in this case, a parallelogram. And so if you graph it out and you can say, oh, I recognize that shape, I can find that graph, I can find that area just using one of our formulas, you absolutely can. This is not a parallelogram, I apologize. This is a trapezoid. If you remember your formulas, or you can, in this case, we're in distance learning, just look them up, I believe in you. The area of a trapezoid is 1/2 base 1 plus base 2, where the bases are the parallel sides, times height, which is the perpendicular. So if I look here, this is my base 1, the parallel side here, base 2, which means that the height is this distance. Now, using my function here, the height for base 1 is -2 plus 3, because we're plugging in for x, and this is 4 plus 3. And my height is the difference between -2 and 4, which is 6. So the integral of -2 to 4 of x plus 3 dx is equal to 1/2 base 1, which is 1, plus base 2, 7, times 6. So we can evaluate the integral absolutely. 1/2 times 8 times 6, which is equal to 24. So instead of an estimate, we can find the exact answer. This works just as well if you have several different sections. So let's look at one here. X minus 3. So when I graph this, the main difference here is that when I have -3 from -2 to 4, I'm looking from here, and I have a negative area here and a small positive area up here. Now, that we will include both, and they are both triangles. So for both of these, we're going to use the triangle formula. So this one here has a negative height, so the area is equal to 1/2 base times height. Whoop. The base is here, and the intercept is 3. just based on our knowledge of the function. So our base goes from -2 to 3, which is 5. And the height is here, and that would be -2 minus 3, so the height is -5. Here we've got a base of 1 and a height of 4 minus 3, which is also 1. So when I'm evaluating the integral for the area between the curve x minus 3 from -2 to 4, we have our first triangle, which is 1/2 times base times height, plus the other triangle, 1/2 times base times height. So -25/2 for the negative triangle, plus 1/2 for the positive triangle, which gives us -24/2 with our final answer. The integral from -2 to 4 of x minus 3 dx is a negative answer, and it's -12, since most of the area is beneath the curve. So you'll have triangles, you'll have trapezoids, you might have rectangles. You're also going to have functions that look like this, and this might be a little bit more challenging to grasp how this is going to connect to our ideas of geometry. So evaluate the integral from 0 to 3 of √9 minus x squared dx. Now the way I always recommend you think about this is tells us that our function is √9 minus x squared. Well, if I do a little bit of manipulation, that means that y squared is equal to 9 minus x squared. Add x squared to both sides, and we get this equation, x squared plus y squared is equal to 9. Well, this is a circle with radius 3, because remember, your circles centered at 0 are x squared plus y squared equals r squared. That's going to be now a circle. We absolutely know a formula to find the area of a circle. So we can graph this out. Since it's only the positive root here, we're only dealing with the positive arc of the circle. And we're going from 0, which is here, to 3, since it says radius 3. That's just lovely. So the area is this right here. So what we're looking at is a positive quarter of a circle. So this is quarter, so 1/4 times pi r squared. What that tells us is then the integral from 0 to 3 of √9 minus x squared dx is equal to 1/4 times pi. The radius, as we've said, is 3. So you get 9/4 pi as the exact answer of your integral. Let me know if you have any questions on any of these problems. And tomorrow you have a workday with lots of students taking the ACT and or working on their thesis.